This is when you log into the Pulumi cloud environment. So you can choose an organization on the left side and then your individual organization. So I created now the environment in my individual. As I mentioned before, I'm using also the individual one. You should have access when you accepted this to this one, and you get all the enterprise features for 30 days. You can head over to the environment tab here and start to create your environments. You saw I created plenty of environments. Just create of environment. You give it a name. The demo environment or demo workshop. Here in my case, there are revisions. So you can see when there's a change, you can roll back to a specific revision, and then you can start to build now here your environment. As you can see, everything is set up. And then you can give it here greetings, hello, and it's available. And if you want to make it available inside Pulumi, you can set it here into the Pulumi config. So let me remove here a little bit of this one. So I can say now if I want that the Pulumi IAC has access to this one, I can say here now the config name is called greetings. And then I can say here example.greetings. And we can see now hello is also here. So that's one part, creating here all your environments. The most interesting part is, and let's go to the one I already created. Here, this is for today's workshop. We have also the possibility to use some of the functions. There's a huge documentation about all the things you can create for Azure, for AWS, and for GCP. There's a login. And here I created now the OIDC. I connected it to my project. I defined the workload pool and the provider inside the workload identity and the service account. So using here a service account on my own. And as you can see now, I pass now the GCP access token to the Pulumi configuration. I also have here environmental variables I can use and a specific bucket name. So that's very simple. So I created here my bucket name because I want to show this in deploying a bucket. So let me open now the next screen to show this now in running pictures. Okay. So, okay. So let's go in my workshop folder. Okay, hope that's big. And we create now a GCP test workshop project. And then I say Pulumi new. I get the wizard asking me if I want to use a template or if I want to use Pulumi AI. Here I just used the template. I say, please use GCP. And we're going to use, that's a little bit. So we use GCP. Let me use GCP Go. Project name default. That's all fine. The stack environment is also default. My GCP project. I will get this from my environment, so I don't need this for the moment. Okay, and we are good to go. Let me show what it's created here. It's created on the Pulumi YAML, the Go mod, and the Go files for everything related around Pulumi, the project. And if I open now my IDE, I'm using IntelliJ. And let me switch now to my IntelliJ. So, okay, so I'm not going to touch anything here, so that stays all the same. So what I'm going to do now is just create now my Pulumi environment file, pulumi.dev.yaml. And the only thing I need now to do is create here environment, the reference to the environment, and the environment name, because I already created it. It's just this the one I took before. So, okay, so just referencing this one, there's nothing else. I did not enter anything additionally here. And to show that it's get the informations out of the environment I just created, I'm going to use also a config. So just importing now the config and say, okay, my bucket should have a specific bucket name. Here, now you see with config require, I point now to the environment where I defined the bucket name. That's it. And hopefully, if I run now Pulumi preview, go tidy Pulumi preview, and if the demo gods are happy with me, we can see, yes, it's going to create the buckets. So let's say Pulumi up. Pulumi up command will now deploy the infrastructure. Ask me if I want to do this. Yes, of course, let's do this. And also creating now the bucket. And as you can see, the bucket name is Engindiri. So it took the informations from my environment. If we go back again and say, oh, there's a change. We want to change the bucket name to Engindiri -2. So, and let's switch again to our, if we now say again, Pulumi up, and you see, it didn't ask me anything about my credentials for Google, so I did not need to set anything. I don't need to create any G-Cloud login. As you can see, it detected already the diff. So we can see now it wants to change the name of the bucket. It probably deletes the bucket. Yes, it's going to delete and replace it with a new bucket. And here we can see it created. It's going to create now with Engindiri -2 the bucket name. I'm not going to do this, but to just show you that I'm not logged in anything, I just revoke everything. You see, there's no credentials set currently. I did not use Google G-Cloud Auf, just use the Pulumi up with the reference. And I mentioned before, if I'm not going to use Pulumi, for example, I just want to use Pulumi environment. Why do I Pulumi environment? So I can now, where are you? That's not what I'm looking for. So we can now, here, we can now, for example, pass the G-Cloud command in. I can say G-Cloud project list. So please use the OIDC connection I created in my environment to use inside G-Cloud. And as you can see with the G-Cloud CLI, I have now access to the project list because I'm using the OIDC provider inside my environment I just created. So, and let me share quickly also how it looks like. Where are you? So here. So let's have a look. The only thing I needed to create inside here was the workload identity federation. So I created here the provider and set up some of the informations here, including the connected service accounts. There's a documentation for all of this. So you can read up how to set up the OIDC connection and how to use Pulumi ESC for your own projects. So stop sharing and head back to the slides. So I just wanted to use this as an introduction for some new functionality. And with this said, go try Pulumi ESC and see if it's helping you. And with this said, I'm going to pass now over to Jay.
So thank you for everybody for joining, and thank you for the pass off. I always like learning about the new things with Pulumi. I personally have not learned, only recently learned about the secrets and whatnot, which I find incredibly cool. So I'm going to have to integrate them into my system as well. So let's talk a little bit about Google Cloud. I'm sure you've all heard of it. I'm sure you all know about Google. Like, I'm sure that's how you do your searches. You all probably, or a lot of you probably have Gmail accounts, so on and so forth. Let's talk a little bit about cloud. What makes Google Cloud different? I always say that every cloud, has its specialty. Let's say that. Every cloud has this thing that it's good at. Every cloud is valid cloud. So, it's not so much like, oh, we're the best cloud in the world or anything like that. Every cloud has got its benefits. I want to talk about what makes Google Cloud specifically different, though. So like, we have the best in class security. Security has been built into everything we do. We take everything seriously when it comes to security. So we have data encrypted at rest, data encrypted in transit. We even have like private compute. So basically, if you have like a VM or something, the compute is actually encrypted to where we can't go in. Google Cloud can't go in and see what's happening. So that's an additional form of security. Hybrid and multi-cloud. As I mentioned, there are so many clouds out there, and a lot of people want to be on multiple clouds for any myriad of reasons. Maybe Cloud A has some features that work for this workload, whereas Cloud B has features that work for this workload. Sometimes it's a high availability thing, various stuff like that. So we actually try to make it easy as possible to enable that choice to be hybrid or multi-cloud. Also, some people are still in their own data centers for XYZ reason. Fully managed no-ops, we have a lot of serverless options. I love to talk about serverless, so I always find that interesting how great our serverless platforms are. Embedded AI and ML, we started as a data company. We're still a data company. So we have invented a lot and created a lot around AI and ML that we want to share, which goes back to the final point of best of Google. Just, everything that we've learned over the years, we want to share with our customers. So, things that we've learned, mistakes that we've made, things we've learned from mistakes as well, things that we've learned that were incredibly successful. We want to bring that mindset to our customers. One thing that I still find very cool, I'm not a network guy, but it's still, even as a non-network guy, it is still very cool to me, is that we are the largest privately managed network, over 100,000 miles of fiber optic cable. So what does that mean? Well, the cable belongs to us. I mean, sometimes, we share a little bit, but generally speaking, cable belongs to us. So it is secure, it is encrypted. And then we also, I forget the exact number, but if we were an ISP, we're not, but if we were an ISP based on our infrastructure investments, we would be like the fourth largest, third largest. So that's really cool. We redact a lot of information that comes through our predefined detectors. And then, as I mentioned, everything is encrypted at rest and in transit by default. Like, you don't have to flip a switch or anything in order to make it happen. It just happens. One thing I also love about Google Cloud, and this is like, this is something customers love, but this is something that I personally love as well. Because I am a huge open source fanatic. I always point out that, like, I've been using Ubuntu since like 4.10. So since 2004, I've been using different open source technologies, running my own Apache servers, et cetera, for years. So I love open source technology. And as you can see here, Google loves open source technology. If we look at the blue kind of column there, these are things that are specific to Google Cloud. So if you look on the left side of the blue column, these are like the open source technologies that exist. And then the right side of that blue column is the product name in Google Cloud that is based on that open source technology. And then the ones that have asterisks are ones that Google actually had direct contribution to, like they created it. Though there are some things that while we didn't create it, we still contribute upstream for a variety of reasons. So as you can see there, Cloud Run is based on Knative, Tecton Cloud Build is based on Tecton, Kubernetes Engine based on Kubernetes, Dataflow Apache Beam, so on and so forth. In this green column are some other open source projects that are not specific to Google Cloud or our Google Cloud offering, but still things that we have designed, contributed. They're under an open source license. People use all the time. So, Angular, Flutter, if you're wanting to build a Flutter and Dart for that matter, because Flutter is more of the framework while Dart is the language for building multi-platform mobile apps. Go, I'm sure a lot of you know Golang, so on and so forth. There's just a lot of stuff out there that we've contributed to with open source. Here's kind of some project stats. A lot of this might be a little dated. So here is like a look at some of the project stats based of things that we've contributed to, and then kind of how important by looking at the stars. That I don't always say that looking at the stars is like the most accurate way, but it is a very good indicator about how popular something is or how impactful something is. Now this, I literally just took this screenshot earlier this morning. You're more than welcome to do it the same way. This is so the CNCF actually publicizes all of the stats for all of their projects. So you can actually look at the URL up there, devstats.cncf.io will give you the stats for every project that is considered part of CNCF. By looking at their GitHub repos. And then, of course, you can append it with like the specific project. So for Kubernetes, you do K8s. If you look here, Google is still the #1 contributor. And you might say, well, that's not fair because, Google invented it. Of course, they're the #1 contributor. You'll notice that when you look at the range, I only controlled for the past year, not since all time. So even still, Google's like the #1 contributor. And that's how important contributing upstream to open source is. Like a lot of companies, a lot of organizations for that matter, open source something, pass it on to an organization and then just kind of divest in it. Not that that's necessarily a bad thing. It's just the reality. But this is showing Google still like committed to the project. They gave Kubernetes away to CNCF, and they're still contributing upstream to it. So we believe strongly in open source technology and supporting open source technology. Now, why are containers important to us? Why did we create Kubernetes? Well, at Google, everything is a container. Like literally everything is a container. If you go to Gmail, you are logging into some containers. If you go to search, you're doing containers. The Play Store, the backend containers, so on and so forth. YouTube, containers. Even Google Cloud is on containers. I always say it's kind of like container inception, if you will, because if you run GKE, Google Kubernetes Engine, it's running GCE VMs underneath it. So you're running, which is standard VM. You're running Kubernetes on top of a virtual machine, but the virtual machine, or you're running a container on top of a virtual machine, but the virtual machine itself is in a container. So it's kind of like container VM inception, if you will. But yeah, so everything's a container. We launch several billion containers per week. And this kind of goes into the idea of containers and like kind of the history of containers. So internally, we created a container system that we still use to this very day called Borg. Borg is based on, Borg is something open source that we created. We named it after the Star Trek, the concept of Borg, one of many and whatnot. It comes from the idea that if we're looking at a data center and we're wanting to build something that is global scale, that can support 1 billion users, so on and so forth, we thought that we need to really rethink how we think of data centers. So what we do is, what we did is like, well, the traditional way of thinking of data centers is a set of servers, like just a set of servers in the hundreds, if not thousands of numbers. What we wanted to do is think of the data center as just one giant server that happens to have multiple nodes, but it's one giant server. And if you have one giant server, the workload should be able to move between the different servers or the different nodes without issue. So that's kind of where we created the Borg containers, which makes it easy to just kind of move stuff around with almost seamlessly. And then, we created that. As time progressed, containers became popularized, I should say, in 2013 when, well, at the time, Cloud, but they rebranded themselves as a company we all know today, Docker, created the Docker engine, which was originally based on LXC, Linux containers, which, funny enough, was based on C groups, which was invented by Google. But I digress there. So when that came out, that's when kind of the modern take of containers really took off. Containers have technically always existed. If we want to be, if we want to be technically correct, root in Unix back in like the 70s was containers. So, but this is the modern version of containers. When that became popular, people started to think, oh, containers are awesome. It's easy to deploy 2, 3, 4 containers. What happens when I need to deploy 100? Like, how do I actually make that work from a networking perspective, from a scaling perspective, security? How do I just manage all of these containers? And a lot of companies came about, a lot of organizations, open source projects, closed source projects came to try to solve this. Google was like, hey, we kind of solved this internally, like, 8 years ago. Let's try to create something based on our experience, and that makes it easier to manage containers. Now, I always want to caveat that Kubernetes is not open source Borg. It's not like we just took our Borg software and then just open sourced it and released it under open source license. It is based on learnings from Borg, things that we have learned about the best practices with managing containers, the best practices with scaling and whatnot, but it's a general purpose open source project because our data centers are very unique. Most people aren't set up like that. And also, a lot of people aren't trying to run a company that hits 1 billion users. I mean, if you are, that's great. But, we want Kubernetes to be general purpose for people who are hitting 1,000 users to people who are hitting 1 billion users. So we open source Kubernetes, and ultimately Kubernetes kind of won, you could argue, the containerization orchestration battle. So we then open sourced it as, or we created a managed service called GKE, and now here we are today with GKE. And we actually launched an autopilot last year, a few years ago, which was essentially what we consider like a serverless, like with a dash between server and less. Kubernetes. It's still Kubernetes at the end of the day. We just take over the node plane. So all you have to focus on is deploying pods and not worry about, well, machine types and what kind of nodes and managing node pools and managing auto scaling, all that fun stuff. Inevitably, we have to talk about AI. AI is here. It's the reality. It is something that is not going away. And as you can kind of see from this image, AI is kind of the next big step. If you're just, if you're looking at things that are happening in the world, we look at kind of, the 90s and the 2000s as kind of being the age of the internet. Internet was the hot new thing. Internet was awesome. Everybody wanted to invest in it. And then we kind of looked, late 2000s through the 2010s, the big investment was mobile. Mobile devices were starting to take off. If you want to extend mobile to include like IoT and edge devices, I would say that falls under the mobile umbrella. So it's like, how do we build more mobile things, more edge compute things? I would say with the 2020s to who knows, AI is the next big shift in technology, and that's where we're going to see a lot of investment. That doesn't necessarily mean that internet and mobile went away. It's just that this is the next big quantum leap in tech. Google has had a lot to do with AI. A lot of companies have, not to say that we invented AI. AI is old. The concept of AI is older than Google by a few decades, for that matter. But we started when we started 26 years ago. We started kind of with the of organizing all the data in the world, and well, now we are like we've kind of evolved with that. We've had to find ways to actually accomplish that. But then how do you organize the data? You have to do it intelligently, and we don't have infinite amount of employees to kind of do that. So that's kind of when we made investments into AI. And this is not like an exhaustive list of everything we've done. This is just like a snapshot of AI contributions, but you can get an idea of like our DeepMind project, you know, using AI to help detect eye disease. We invented the transformer back in 2017. The T and GPT stand for transformer. We have the open source BERT language, text-to-text transformer, a bunch of different stuff that we've created, and it's going to continue happening. And we've also contributed to a lot of research papers and whatnot. So it's kind of cool that we do a lot with AI, and we want to help customers and help users understand AI as good as possible. We also believe in responsible AI, which kind of sounds like a marketing term or whatever, but it is a real thing, because the question becomes like, hey, you know, what happens, especially in this LLM world, where LLMs are trained on just massive amounts of text data? Like, where are we sourcing the data from? Are we just finding random articles and sourcing it, or are we trying to only source things that we have legal access to do it, and it's ethical and lawful to do it? That's kind of stuff we want to think about. There's a lot of other things that we consider, and that honestly every organization should consider. Now that AI is becoming a big thing, everybody's investing in AI. I always argue that responsible AI is incredibly important, and it's not just in terms of like legality and ethics, but also social responsibility. You don't want like inherent bias in your AI. So stuff like that is stuff that I always say, like not just Google, like any company that's thinking about building AI models or doing anything with AI should consider. Some Gen AI trends that we're seeing, you know, as we're kind of like almost 2 years into the Gen AI revolution. You know, a lot of people are wanting unlimited context, multimodality, mixture of experts, predictive AI, privacy. When I just kind of mentioned that earlier, and then productization. Like, cool, Gen AI is awesome. How do I actually use it to do anything? Let's talk a little bit about large language models. I kind of want to level set before I just start, you know, assuming anything. So what are large language models? Well, the way to look at it is it's just the way I always say, it's like, just think of it as like the world's largest dictionary, or the world's largest reference book or something, or the world's largest encyclopedia set. For those of you who are younger than me, encyclopedias were books that they were the book version of Wikipedia, let's put it that way, but they were always out of date because they only printed them like once a year. Anyway, so what they do is the algorithm. It's an algorithm that that recognizes human language, as the name suggests, large language model. It is pre-trained on just massive amounts of data. In order for you to have that large model, you need to have a lot of data to do that, like a lot of data. They're usually pre-trained on a large corpus of text, then fine-tuned for specific tasks. So what we'll probably wind up seeing in the future, my prediction would be like, we'll have a few companies that have like generic LLMs for specific use cases. And then as time progresses, we'll have like specialized LLMs that companies launch, like whatever, for like gaming or for healthcare or for construction. So you'll start seeing some more fine-tuning on specific tasks. And yeah, all generative AI is based on large language models. So what can large language models help us with? Well, I'm sure all of us have used like one of the chat bots, whether it be one of the public ones such as ChatGPT or Gemini, but also maybe just a chat bot on a website, you know, for support, customer support, stuff like that. Well, these are all now starting to integrate LLMs to make it easier. It makes it easier to perform basic tasks. And it makes it a little easier to do things that maybe aren't included in training examples. They can understand human language and how we interact, because, you know, there are things in human language that aren't necessarily black and white, like slang and whatnot. So, you know, can we understand what you mean when you say that? And then, of course, finding patterns and connections in a lot of data, because, again, it's a massive amount of data. If it can't make that connection of what it is you're trying to say or figure out context, like if I say Bill, do I mean a guy named Bill? Do I mean a bill that I have to pay? Do I mean the bill of a duck? Stuff like that. or a platypus in this case. So, you know, you want that kind of context as well, and it needs to be able to search the data to get that. There are a number of LLMs, and this is by no means an exhaustive list. I'm sure, like, since I started talking, another open source LLM was launched. So this is by no means an exhaustive list. But these are just some popular ones that you've probably heard thrown around. So, you know, with closed source, there are kind of three major ones right now. There's ChatGPT by OpenAI, Gemini by Google Cloud, or excuse me, by Google, and then Claude, which is by Anthropic. But then there's also a number of open source ones that are kind of free to use. Some of them do have a few restrictions, which I'll talk about a little bit. But, you know, we have Llama 3 from Meta, Gemma from Google, which is kind of an open use version of Gemini, Aya from Cohere, Mistral AI has a number of stuff, and the list goes on. There's just so many different LLMs out there. A lot of them, I wouldn't say are true open source, and here's why I say that. True open source means that, like, I can do whatever I want with the technology. It's up to me. A lot of these are open source, except they do have a few guardrails. For example, they don't want models being used to do things that are against our ethical guidelines, creating certain text, creating certain images, stuff like that. So we're like, you're free to use the model however you want, except for these use cases that we consider against our ethics, and we do not want our models to be used for these. But for the most part, they're open source. Let's talk a little bit about how to deploy these models on GKE. I mentioned that there's open source ones. Open source ones you can download, you can deploy, you can use however you want. We're going to talk about how to specifically use it with GKE. So bear with me one second as I do this switch here. All right. It's always fun doing the kind of switch screen thing.
If we have any questions, feel free to type in the chat. I'm here to answer them. So, yeah.
Yes, please ask. Feel free to ask us anything. It'll make it a fun game. See if you can stump us. All right, I'm going to expand this a little bit so that it's a little easier for everybody to see. Bear with me one second. Okay, well, it's a little big, but we'll make it work. And by the way, this is all public code that I've made, so feel free to, like, play with it, change it however you want, download it. Even if you want to contribute upstream, I am supportive of that, so please do that as well. So what this is this is a standard Pulumi kind of setup with using Python. I choose Python 1 because it's the one I'm the most comfortable with, though I have used TypeScript before for Pulumi, and I'm still, like, getting used to using Go. But yeah, so this is kind of the Python. And also, one thing worth noticing with Python is, you know, Python's still very much, and who knows what the future will hold, but Python's still pretty much like the language for data scientists, the language for ML. So why another reason I choose Python is because, you know, if we're talking about ML users, people deploying ML, that kind of thing, how do we make it as easy as possible for them? So Python is one way, because you're using a language they already use day in and day out. They are something they're comfortable with. And this is one of the great things about Pulumi, and why I'm a huge fan of it, is that I get to use the code that I'm familiar with. I always find it funny when they say infrastructure as code, and yet it's like a whole different code language, whereas this is like true infrastructure as code, I think, because I'm actually using like a natural programming language. Anyway, so as you can
see, can I interrupt you shortly? We have a question from Mate asking, what's the difference between Gemini and Gemma?
Yes, so Gemma is definitely smaller. So that's something that I would point out. Gemini is definitely bigger. It's restricted to the Google ecosystem. We're contributing to both of them. I would say that Gemini, being that it's commercial, is a little more, I guess, what's the word I'm looking for? It is more robust, more capable of doing things like it has a larger context window, so on and so forth. Also, it's already managed, whereas using Gemma, it's kind of self-managed, like it's an open source tool. So I download it, I install it on something, whether it's GKE, whether it's a VM, whether it's on my own laptop. I have to manage it, I have to create it, I have to build all the kind of bindings around it, all that fun stuff. Whereas Gemini is kind of ready to go. So because Gemini is ready to go, it's already in Google's ecosystem. It's capable of doing the global scaling. It can do more, and it's easier to use. But Gemma is based on it and based on a lot of the same training, just not as robust. If that makes sense. So what we have here is what looks like a very standard Python program, if you've ever seen one. I'm doing some imports here of different libraries. I've set some basic variables here, so I'm going to probably update this to use the ESC, make it a little easier for me, because right now it just creates a file, like a YAML file with all these configurations, and this is just kind of pulling from that YAML file and setting some variables. I create a cluster here, as you can see. Very standard stuff. All of this stuff is, by the way, is documented. Pulumi has great documentation. They also have like this AI tool that you can ask it, just, hey, create a sample that creates a Kubernetes cluster on Google in Python or in TypeScript, and it'll spit out some code, which, you'll have to tweak, but it's pretty good. So I create a node pool. This node pool is going to have NVIDIA L4 GPUs in particular too, as you can see right here. I'm going to use the latest driver that's available. You can also hard code it if you want to for a specific version if you want, but I always just say latest because it's easier. The NVIDIA driver setup, some permission stuff. It's set to auto scale, no more than 2 though. Auto repair or auto upgrade, which is features of GKE. It can fix nodes that are problematic. It can also automatically upgrade to the latest versions. Some certificate stuff so that I can log into it afterwards, into the context. I created, so this is actually kind of cool. So a lot of us who've used Kubernetes in any kind of method have probably used something like, you have created Kubernetes manifest as YAML. With Pulumi, you can actually create the manifest. I mean, you can still deploy a YAML manifest if that's what you choose to do, or even customize our Helm charts. But you can actually just, put the manifest in natural language. And so that's pretty much what I did here. It's going to pull Hugging Face, which is kind of an interface or inferencing tool for various LLMs, various open source LLMs as well. But then it's going to also use the Mixtral 8x7b, just this particular version. I could patch it into a more up-to-date one. You can see it's pulling the specific container, all that good stuff. And yeah, so in my code, it is actually going to pull, as you can see, give me 1 second. As you can see, I went ahead and imported the code. So as Mixtral, so towards the bottom, I go ahead and deploy the service, and it's good to go. It takes a while to run, so I went ahead and ran it for you. So you can see I went ahead and did, where we got it right here. Oh yeah, so I did a Pulumi up. As you can see, it went ahead and built everything out. It kind of said, hey, this is the stuff that I'm going to build per this Pulumi up command. And it went ahead and did it. It kind of told me how long it took. Creating the cluster, as you can see, was the longest part, though everything else was, I guess, paled in comparison in terms of time. But when all was said and done, it deployed a cluster. And I'll actually show you what that cluster looks like. And the cluster actually has the LLM in it, so that's kind of cool too. Let's see here. Oh, there we go.
I put the code as a sticky handout in the top of the in your view of BigMarker. You should see this all. So it's the Mixtral demo code. It's the handout, or look in the handout tab so you can see the code and try this.
Yeah. So as you can see, this is a This is the Google Cloud console. This is something, if you ever log in, if you've logged into Google Cloud, if you're going to log into Google Cloud, this is something you're going to be familiar with. I'm in the Kubernetes Engine, Kubernetes Engine portion, or that part. So it's listing all of my clusters. This is one that I created. I actually created it like an hour ago or something like that. So when I ran the initial code, as you can see, it's running a specific version. It has an endpoint, all that fun stuff. And yeah, so it's using kubedns. I can make any of these settings that you're seeing here that are disabled, enabled, specific IP ranges, etc., are all things that you can actually set within Pulumi. Like there's support in the libraries to set that. So it's really cool that if I wanted to change any of these, I can easily just change it. If I wanted to use a TPU instead of a GPU, for example, I can do that. And then we can also like get some visibility into like the workloads that are being used. So let me see here, old cluster that no longer exists. So yeah, so, oh, well, that's fun. Yeah, so the pod's just restarting after pulling all the images. But yeah, so this kind of gives you an idea of how it all works. Then of course I have my gateways and whatnot. I have a fully functioning, where are the services? Here we go. So like an exposure here, this will be down after a while, so you won't be able to hit it. So, but yeah, so this is like an API endpoint that if you were to write an app, you can, and you'd want to obviously look at the Hugging Face and the Mixtral documentation on like how you send things, how you do curl commands, whatnot. But you can actually now make a curl command directly to the endpoint on your Kubernetes cluster, and then go ahead and do the interface with the large language model that's hosted on it. And this would also be great for your developers. I always argue, one of the fun things that I've always tried to argue is that personally, I believe that Gen AI is not AI. I mean, it is, obviously it's in its name, but I always think from a use case standpoint, it's really an app thing, because Gen AI is an API call. Like somebody already built the model for you, and you're not really tweaking the model, especially if it's proprietary. You're just kind of using it with an API call. So I always say that, yeah, Gen AI is developer centric. So now you're building applications on your cluster. You're deploying stuff with Pulumi to build, to deploy your application. Maybe it's in your CI/CD pipeline. I also have the models on my cluster. So that's also a nice thing too for like security purposes, because sometimes people want to create a private cluster and not have things publicly exposed. So that's always an option. Now, I did talk about Gen AI. We actually have ways to use traditional AI on Kubernetes. And this isn't specific to GKE. This could be, I mean, some things are like TPUs are something that are Google specific. They're essentially, whereas GPUs were like, well, I mean, as the name suggests, graphic processing unit. They were originally built for doing graphics, but then a bunch of people, realized, hey, this is actually pretty awesome for using for AI use cases. TPUs, tensor processing units, were something developed by Google for internal use for AI. And it's specifically for AI use cases, for processing models and whatnot. And it's something that's only available at Google today. It's like not something you can install in another data center. But other than that, like pretty much everything here is open source, not specific to GKE. Can be used on any kind of Kubernetes API compliant background. But as you can see, you have the hardware here. You have some of the setups like GCS Fuse, or which is based on Fuse, local SSD, stuff like that. Q, which is part of one of the SIGs at CNCF, which is job queuing. Here are some distributed compute frameworks, workflow processing. All of these are open source. Custom frameworks, if you've built something internally that is proprietary to your organization, you can even launch that on Kubernetes. It's entirely possible. Tools and libraries, all that fun stuff. And so you can build this entire thing like on Kubernetes. I was at KubeCon last year, KubeCon North America in Chicago. And then I was also at the Kubernetes 10th birthday party, I want to say like a month or two ago, whenever that was. And it was all about like you know, a lot of the common themes people were talking about is like, you know, first 10 years of Kubernetes were all about apps, mobile apps, web apps, that kind of thing, batch apps, backend stuff as well. What does the next 10 years of Kubernetes look like? And a lot of people are starting to believe, you know, AI. We can do AI. We can do distributed training on Kubernetes with AI, which is, we can do AI distributed training on Kubernetes. There, with, you know, the variety of technology that exists out there, we can just continue, you know, deploy it on Kubernetes. That gives us the ability to scale better and whatnot. So it only makes sense. So, you know, there are many ways to do that. You know, one thing that we see a lot of people want to use is developing a LLM, or when we use an LLM, is creating what we call a RAG, or retrieval. So basically, one way to think of it is, you know, I have a proprietary LLM. For a variety of reasons, the LLM is not trained on my data. You know, Google and a lot of other companies are starting to promise that, like, look, if you're paying to use our LLM, we aren't going to break your trust. We're not going to go ahead and take all of your code, deploy, you know, and or whatever it is you're doing, and use it to further train our model. We have our own ways of training our model that's not based on your data. But then the question becomes, like, well, how do I make it specific to my use case? Because your LLM doesn't know my code. Your LLM's never seen my internal documentation. So what we do is we have this RAG, which is essentially a database, usually Postgres, but not exclusively, of, you know, vector databases. You can install PG Vector on Postgres, and boom, you can install PG Vector on Postgres, and you've got a vector database. So what winds up happening is your data is kind of stored on that database. Your proprietary data is stored on that database. That's specific to you, and kind of when you're making the call to the LLM, it's checking against that database, and then it's checking the LLM, and then giving like a specific answer for your use case. So that's a way for you to customize the LLM without a lot of fine tuning, a lot of tweaking, and without having to worry about how do I get my data there without training the LLM myself. This is kind of an architecture of what a typical use case can look like, or what a typical Kubernetes cluster running on Google Cloud, different projects to deploy. Everything here is open source, I guess, except for maybe cloud storage. But the Kubernetes cluster you can use. This is Cloud SQL with PG Vector, but you can use any. You could just download open source Postgres and spin it up on something. Jupyter Notebooks, Ray, Hugging Face, Flask, so on and so forth. So this was
short question, Jay.
Yes.
So we have a question from Arseni. He asking, so we deployed Mixtral on GKE. How exactly does it differ from just deploying Mixtral with a Docker image? Is it more scalable, efficient?
Yeah, it's more scalable. So we're deploying Mixtral on the Mixtral we're deploying is part of a container. So what we're doing is we're downloading the Hugging Face to interface with Mixtral, because Mixtral is just the model. Hugging Face then downloads, part of that process. It downloads the model and stores it in a storage bucket. Hugging Face interfaces with it or acts as that interfacing layer. So just having the pure Docker container doesn't give you the scalability that you need, because individual Docker containers do not scale, not really. Theoretically, I guess they can. It can continue to eat up memory on your machine, but on your VM or your laptop, wherever it is you're hosting it. But it doesn't scale to cloud length. So what you would want is you would want an orchestration layer to do that. So you're still using a Docker image. Like I pulled it from a Docker repo. It's just that it's deployed on Kubernetes for scaling. Like individual, in general, you wouldn't use kind of what I alluded to earlier with like the problem with containers. When people were like, oh, I've got 2 containers. This is easy to run, but I have now 100. How do I orchestrate it? Orchestrating an individual Docker container is probably not scalable for your business, or whatever your use case is. Orchestrating it on Kubernetes gives you that scalability, gives you that management layer. That orchestration layer makes it easier. But yeah, so this is all. This is kind of a architecture. But I'm not going to be, kind of a tease. I'm not going to be showing you this demo. But if you sign up for Pulumi Up, you'll get to see this demo of running LLMs or training models directly on GKE. Oh, by the way, you might be curious and like, hey, how do I use Google Cloud or whatnot? Well, you know what? If you sign up right now on cloud.google.com with like your email address or whatever, you get $300 credit. Then you can use it for whatever you want. And we don't ask for your credit card. So basically, like once you get that $300 credit, it just shuts everything down. You can put in a credit card if you want to continue using it. We also have a generous like free tier for like kind of small projects and whatnot. Different products have different like not requirements, but different like limitations or quotas or whatnot. So to get all the information, I recommend going to cloud.google.com/free to learn, what the different offerings are for the different products when it comes to that free tier. That's if you go above that 300, credits and you want to just kind of experiment. And that is all I have. So I'm going to kick it back here.
Okay, awesome. Thanks a lot. So let me pull over. Okay, so I shared also the GCP free credits link in the handout section, and then also the demo code if you want to recreate what Jay showed us. So highly encouraged to try this out. You have access to the demo instance, and now with the free cloud credits, also the possibility to use the resources. Again, that's the link. That's the name of the demo account we created on our app cloud. So deploying -LLMs minus GKE minus Pulumi is your organization. If it's not set it by default because you already played with Pulumi maybe and you want to try some of the enterprise features, you just need to set this with the Pulumi CLI. So feel free to try this out. That's something we did. And before we end up, the little to-do list for you folks. Yeah, try Pulumi with GCP at home. Give it a try. Join our Pulumi Slack, for example, and let us know if you have any question. Jay, you should be also in the Pulumi community Slack, I think. Somehow, yeah, can also ask questions there. We have also a dedicated, I think, a Google channel, so you can also ask there questions. Feel free. Jay mentioned this also. He will present his demo also on the Pulumi app one in more detail. So I'm also very eager for this talk. It's on the 18th, so it's free. You can register. I think I put here the link also here. So pulumi.com/app. Just go register yourself. It's free and join some awesome speakers. Yeah, I mentioned the community Slack. Just join if you have any questions and you want to see what other people doing with Pulumi. Sign up. I mentioned also, Jay also mentioned the Pulumi AI. I put the link also in the chat. Try Pulumi AI.